Hi everyone, this is our second part. We're gonna tackle unit step function. It's also called heavy side function. But before that, I want us to go back. Remember, I told you about the typical function that we encounter. It's a constant function. We have a linear function, a quadratic function. But I forgot there's this one who usually come also when you have f of x equal to sine of x. And then when you have f of x equal to cos of x. So here, please, I just want you to be accurate. So you know that a sine, it starts from like this, all right? And then for cos, you start from, that's a 0, right? You start by a certain amplitude, and then you go like this, all right? So unfortunately, I didn't do any example with this. If I encounter or if you have a question you can send, I will do it. For now, let's jump on the topic of today. Okay, unit step function. All right, it's written u. Okay, u of t minus a, or you can also write it as h. Okay, capital H of t minus a, all right? And this is defined as 0 when t is less than a, and 1 when t is greater or equal to a. This is not given to you in the formula sheet, so you have to know it, all right? Okay. So, for example, if I have a function which is f of x or f of t, because I'm in a time domain, f of t, u of t minus a, so our equation will be therefore f of t, and then this one doesn't change, 0 when t is less than a, and 1 when t is greater or equal to a. And then this function definitely become as 0 times f of t. It's going to give you 0. And then I have f of t times 1, which is f of t. So the restriction remains as it is. So if you know this, you are good to go, my dear. You are good to go. For example, and then I told you most of the time you're going to have a constant function, a quadratic function, or a linear function, or a trig function with sine or cos. So let's tackle already one question. For example, if we have f of t equal to 3 u of t minus 1, for example, if they tell you to graph something simple like that, it will be what? You have 1 here. So anything before 1, it is 0. First of all, you have to graph that. It's going to have 3, and then here is 0, and here it's going to be t, less than 1, and then you have 1 when t is greater or equal to 1, okay? So definitely, you multiply them out, okay? It's going to be 0, and here it's going to be 3, and then you have this and that. Okay, so this is what we're gonna plot here. All right, so we're gonna have what? This is our 1. This is the most important. This is what to control. It's control your function. All right, so at 1, so a unit step, in other way, it's a on and off type of function. On is 0, it's off, on is 1. It's like a step. It starts somewhere, it ends somewhere. All right, so this means this function equal to 0 when t is less than 1. So anything less than 1 is 0. Anything less than 1, this is my 1. So anything that's come this side It's 0. So it's right there. And then when it's reached to 1, what happened? Look at now. What happened? When t equal to 1, then our function equal to 3. So I'm going to be right here. You see that jump? There we go. All right. Good. So another example will be this one. The simplest one will be if they gave you f of t equal to u t minus 2. So definitely this one is defined like that. 0, it's going to give you t less than 2, and 1 when t is greater or equal to 2. So this one is going to be so simple because I'm going to have my 2 here. That is the essence, that's what's control everything. I have 2 here, and then what will be my when it reached, so before that it's gonna be it's gonna be 0. All right, it's gonna be 0. Actually I can go all the way like this, so anything that comes before that is 0, doesn't matter. And then what happened when you reach to 2? It's 1. When you reach to 2, it's 10. There we go. Okay, something like that. So you can write it like that. Okay, 1. There you go. So now let's go to another question. Yeah. Which question I'm having? Yeah. So they can give you something like this. Very simple. We are in time domain. Okay. So f of t equal to t u of t minus 1, for example. Simple. So how do I draw this one? Same thing. I'm here. Where's the control is right here. So it's gonna be, this is my 1. All right. So that's where the things happen. What happened? Number 1, you have to write. Where's my number 1? You have to first of all write in a mathematical expression. This is gonna give you 0 when t equal to less than 1, and then this one gonna give you that function t when t is what? Greater or equal to 1. Please. So let's see here. No problem. When t equal to less than 1, it's no problem. All right, it gives you 0. Now here the problem comes here. What will happen when t is greater or equal to 1? What will happen? You take that value, you put it right there. You take 1, you put it, remember that. You take that number, you put it here. It's going to give you 1. When t equal to 1, f of t is going to be equal to 1 also. So when t equal to 1, f of t is here. It's going to be also equal to 1. Okay, I'm standing right here. All right. So for you to draw a graph, you need 2 points. Definitely, I can draw it because I know already that this is a linear function, and then my a is positive, so it goes like this. Yeah, there we go. But if you want to be more precise, and if you want to be mathematically, like you want to impress me, you will say what? Definitely your graph will look like that. You can say, okay, let me choose 2. If I choose 2, because I know to draw a line, I need 2 points. So if I take 2, then if t equal to 2, then my f of t will be also 2. So I'm going to put this 2. So it's going to give me blah, 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 blah. There you go. Okay. But remember, this thing doesn't stop. It does continue. Because we say t is greater or equal. Greater. So continue. All right. So that's it. Let's see another question. Okay, let's jump to pulse function. A pulse function is represented like this. F of t equal to u t minus a bracket minus u t minus b, and b is always greater than a. And you always see minus here, you're gonna see minus here, minus here. This shows that this is when it's turned on and this is when it's turned off, minus. All right, okay. So now let's get a practical example. All right, first of all, let me define this type of pulse function, all right, in terms of piecewise. How do I represent this mathematically? All right, this function, it gives you 0 when t is what? Less than a. All right, and it gives you 1 when t is between what? 0 less than or equal to a, and what else? Less than b. What did I write here? It's give you 1 when we have t is between a and b, between these 2 points. All right, and then it give you 0 when t is what? Greater or equal to b. This is the most important thing. So your focus is here. All right, so to write this thing, you will, first of all, you have this, so you start by you putting 1, all right, and then you put those 2 value, you have a and b here, and then you have t here. All right, okay, and then this one should be less or equal to, and then this one should be less than, and then you can fill here t should be what? Less than a, and 0 here, t should be what? Greater equal to b. So here is the opposite of that, and this side is the opposite of that. You see that? I don't know if you understand, but this is the most important. You start here, you start with the middle point, very important, where you have your limits. Okay, if you can memorize that part only, then I'm happy. So this what will happen. So f of t will be equal to 1 where I'm gonna take these 2 value, I'll put a, this one, t, and 3 here. So this one will be what? Less or equal, and this like that. And then we go ahead. The other point will be 0, and here 0. T will be equal to less than 1, and t will be equal to greater or equal to 3. There we go. It's so simple. And from there, you can graph your point. There we go. So now let's graph this. T equal to 0 when we have what? We have 1 here. Okay, so it's equal to 0. Anything less than 1 to 0. Okay, now we are here in this point, the second one, the second part here. T is between 1 and 3. We put my 3 is right here, so T is between this part. What do I do? What do I do here? I take this value, I put it where there's T, but here you already see that it's a constant, so it's gonna be that point all the way. It's gonna be that constant. This is my 1 here, so it's gonna be that line, but it should stop right there between 1 and 2, right? And then anything greater than 3, it gives you 0. Okay, 0. So this can be written like that. On and off function. I hope you understand this. I believe so. I want to try to believe that you understand this. But now let me make this question to be more interesting. All right. For example, the very same question. I want to make it interesting. So let's see. You multiply with a function. Let's say, for example, I multiply my f of t equal to. Let's say I have t minus 1 u of what? T minus 1 minus u t minus 3. Let me make it more interesting. So I'm multiplying this factor by that. So what's the first thing to do? You already know it's going to give you f of t will be equal to t minus 1. Okay, and I open bracket. Obviously, I start with the one that I know. I'm going to take this. It's going to give me, I have 1 here and I have 3 here. And I have t right there. So it's going to give me 1 is less or equal to t. And then this side is going to be less than 3. And then here it's going to be 0. And t will be equal to less than 1. And here it's going to give me 0. So t will be equal to greater or equal to 3. Alright. So simply we multiply this function with this. So it's going to become basically going to be my f of t will be equal to 0, t less than 1. And here it's going to be that value t minus 1 when t is less or equal to t, and t is less than 3, and this one also will be 0, t will be greater or equal to 3. Very important. You see that? So now we can graph this. To graph this, if you guys pass this and then we are happy, we're going to continue. We're going to do some other function. All right? I can take my point. I have 1 here. I have 0. I have 3 here. All right? So definitely we know where is that function. The function is right here. Definitely we know when t is less than 1, it's 0. Right? And what will happen in this interval? I will definitely, what did I write here? Sorry, this is 1 and 3, right? Sorry about that. So it's 1 and 3, 1 and 3, sorry, 1 and 3. I don't know why I wrote t there. All right, so I'll take this value. I take this, I put it here. When t equal to 1, I put it here. It's going to give me 1 minus 1. It's give me 0. I'm right here. When t equal to 3, I put it here. All right. Maybe 3 minus 1. Okay, let me write it here so that you can see. When if t equal to 1, f of t will be equal to what? 0. If t equal to 3, f of t will be equal to what? It's going to be 3 minus 1, which is going to be 2. So it's based on this interval, this restriction. I don't, because I already have 2 points. To draw a line, I need 2 points. So why should they struggle? I'm going to take these 2 points in the restriction, please. Okay. If I take another point, it's not going to be in that interval. So you must be very careful. You just use what you have. Please, I'm insisting. So here it's going to give me what? If t equal to 1, I'm here at 0. All right. And if t equal to 3, it's going to give me 2. What is 2? 2 is right here. Okay. So my graph will look like this. Okay. And what will happen when t here, I'm now here in the last interval. When t equal to greater or equal to 0 or to 3, it's going to be 0 in here. So this is my graph. If you master this, you are happy. I'm happy also. So you can solve any question that involve unit step function or piecewise function. All right. So now the next topic that I want to do. Actually, I'm supposed to how to take this type of function, all right, and transform it this way. You can do it. You can take this. Remember, this is the most important thing. You can definitely do that. So I'm gonna stop this video. I don't want it to be very long, and we're gonna go for delta function. Wait. Yeah, now let me show you this one first, and then we're gonna go for delta function.